Hey guys, this is a step-by-step solution to one of the newer math papers of May-June 2024. So without further ado, let's get into it. Question 1a. On the axis, sketch the graph stating the intercepts of the axis. So whenever you need to sketch a graph, you need to know the y-intercept, the x-intercept, and the shape of the graph. And since you have the equation, you can kind of tell that it's a cubic graph. So for cubic graphs, it can either be this shape or this shape. And this shape is positive, this is negative. If you look at this equation, you can tell that the cubic graph will be negative. So this should be the shape. And to find the x-intercept, you can just tell from the expansion of the equation. So it will be x equals minus 2, x equals 1 over 2, and x equals minus 5. To find the y-intercept, you can expand. And once you expand, you should be getting 2. So the y-intercept will be 2. And now you just need to plot the points. So since the y-intercept is 2, and then minus 5, minus 2, half. So the graph should be something like this. 1b, hence solve the inequality when it's larger than or equal to 0. So when it's larger than or equal to 0, it will be above the x-axis, which is this part. So you can tell that it will be x is less than or equal to 5, or minus 2 less than or equal to x less than or equal to 1 over 2. Question 2. The polynomial p is such that this, and then find px in a form where qx is a polynomial and r is a constant. So this question is about factor theorem, and if you look at this part of the question, r is actually referring to the remainder. So you can expect that there will be a remainder when you divide. Okay, so after I've divided everything, the remainder is 5. And the question wants you to find px in the form. So qx is the part on top. Qx is 3x squared minus 10x minus 8. And r equals 5. So if you rewrite px, so yeah, this is the answer. Hence, write the expression px minus 5 as the product of linear factors. So you just copy this Okay, so the 5 minus 5 cancels out, and you just factorize this part, which becomes x minus 4 and 3x plus 2. So this is the answer. Okay, so for question C, you have px from part A, and since the question wants px equals 5, and you know the answer from part A already has a plus 5, if you move it to the other side, it will become 0, so actually it will be 2x minus 5, x minus 4, 3x plus 2 equals to 0. So you can find the solution from here. Yeah. Question 3. Write this where x is larger than 1 as a single log to base 10, giving your answer in its simplest form. Okay, so for this question, the 1 can be written as log base 10, 10, and plus log x squared minus 1. The base for this logarithm is also 10, but usually the logarithms with base 10 is like not written, but it's like known that it will be 10. And you can use the laws of indices to simplify this. And here you can cancel this. Part B, solve the equation, giving your answer in the form of this, where A, B, and C are constants. So first of all, you need to notice that both sides, for the logarithm on both sides, the base is different, so you need to change the base first. So before I change the base, I will just rewrite this using the laws of logs so that it's easier. And then I want to change to base 5. Okay, now you have the both sides of the equation has the log base 5 x plus 1, and you can let y equals log 5 x plus 1, so that it's easier to work out. So 4y equals 9 over y, and you rearrange y should be plus minus 3 over 2. So log base 5 x plus 1 is 3 over 2. Log base 5 x plus 1 equals minus 3 over 2. 5 to the power of 3 over 2 equals 2x plus 1. And you can rewrite 5 to the power 3 over 2 as square root 5 cubed minus 1 equals to x. 5 cubed is 125 minus 1 equals x. And since the question wants in the form of a plus b root c, you can just rewrite it. Minus 1 plus 5 root 5. Okay, so this is the first answer. Second answer, 5 power of minus 3 over 2 equals to x plus 1. For this part of the question, honestly, you can just key it into the calculator and let it give the simplest form for you, and then you can just write it as the answer. Question 4a. The first three terms in ascending powers of x in the expansion of this or this, where n, p, and q are constants. Find the values of n, p, and q. So we need to use the formula to expand. Okay, so for this one, n0 is nc0, and anything that's nc0, which is the 1, so it'll be 1 times 3 to the power of n, and anything that's to the power of 0 is 1 as well, so it will just be 3 to the power of n. And then this is nc1, and anything that's c1 will be n, and then times 3 to the power of n minus 1 px plus n2 3n minus 2 p squared x squared. Okay, so you can compare this equation with this part given in the question. So 3 to the power of n is 2, 4, 3. And you can use logs to figure out n. N will be 5. And then the second part of the equation, which is this part, and 3. So this part is equal to 810x. And since you know n is 5, you can sub it in. And you can cancel the x here as well. So p will be 2. The last part of the equation, n2 and c2. N is 5, so 5c2 times 3, 3. you can cancel the x squared and key into the calculator. Q equals 1080, and that should be the answer. Find the term independent of y in the expansion. Give your answer in exact form. So you can just key into the equation as well. 0, 6. But then from this part of the equation, you can tell that when you expand, you will actually get y to the power of 6, and you won't be able to get the term independent of y. In order to get the term independent of y, you need to take note that this part is actually a fraction, so you need the top and bottom to have the same power on y. So for example, y to the power 4 and y to the power 4, so they will both cancel out. So you need to find out what combination of the powers here will give you the same power on the y, and it will actually be 6, 2, 4, and 2. So when you expand this, you will get 16y to the power 4, 1 over 9 y to the power 4. So as you can see, the fraction has the same, the y on the fraction has the same power, so it will cancel out, leaving this as the term independent of y. The diagram shows the graph of y equals a cos bx plus c for minus 360 degrees less than or equal to x less than or equal to 360, where a, b, and c are constants. Find the value of a, b, and c. So a is the amplitude, b is the period, and c is like when you move up or down. And if you see the graph, this part is actually like the middle of the cos graph. So the amplitude is 1, 2, 3, 4, 5. It's 5. So a equals to 5. For b, you can think how many cos graphs can be in the 360 degrees. So a cos graph typically looks like this. And in this question, in 360, it's actually 3/4 of this entire graph. So b should be 3 over 4. And for c, it's whether the original graph moves up or moves down. So the original cos graph would be 5 minus 5, something like that. And since originally the top would be 5, but now it's 1, it has moved down by 4. So minus 4, because if it moves down, it would be negative. If it moves up, it would be positive. Part B, the line y equals p is a tangent to the curve. Write down the possible values of p. So a sine graph looks like this. And for there to be a tangent on this graph, it will either be on the maximum or the minimum. And from this equation, you can tell that the amplitude is 2 minus 2. Yeah. And this part 3, tells you that the graph has shifted up tree by tree. So instead of 2 minus 2, the new value will be 5, 1. And because of that, you can tell that P equals 5 and P equals 1. So integrate this, giving your answer in exact form. You can do the integration separately first. So this is the first part of this equation. And for the second part, it will be this. So I will rewrite the equation just to make integrating a lot more easier. And when you integrate, you add to the power, which is the opposite of differentiating. And always remember to divide by the differentiation of the term inside and then the power. And then you can simplify this. When you key into the calculator, you should get this answer. Okay, so now that you have the integration of both parts of the question, you can just combine them and it will be ln 5 minus 6 roots 6 over 7. So this is the answer. And question 7. Given that 2 plus cotangent theta equals 3x and sine theta equals root y, find y in terms of x. So these are the trigonometric rules. So let's start the question. So you can rewrite the sine theta as this. Because you squared the sine theta first, you should also square the root y, and then 1 over. So 1 over y. And 1 over y is equal to 1 over sine square theta. So you have your first equation. And then you can rewrite this. Okay, so you will square the cotangent because we are using the second rule, and the cotangent is squared here. So we're just like fulfilling it. So now we have the value for cosec and also cotangent. So we just sub it in. 1 plus and to find y in terms of x, you can just rearrange this equation. So this is the answer. Okay, so question 8, solve the equation for this and give your answer in terms of y. Okay, so pi over 2 is 1.57, just for reference. And then you can just rearrange this equation for now. Since this is squared, the entire thing is actually squared. Then you square root. Okay, so you have to key in this part of the equation into the calculator. And the first solution you should get is pi over 6. This is the easiest solution. And then you can just take pi over 6 plus pi over 3, which should get you pi over 2 and pi over 4. And pi over 4 is within the range, so it's one of the answers. So to find the second answer, you can use the second quadrant, which would be pi minus the initial answer, which is pi over 6. So you should get 5 pi over 6 and do the same thing. The answer would be 7 pi over 12. But however, 7 pi over 12 is not within the range, so this is not the answer. And then you can try the negative quadrants. For the negative quadrant, pi over 6, the base angle will be minus pi over 6. Same thing, pi over 12. Pi over 12 is within the quadrant, so it's the answer. And then the second quadrant would be minus 5 pi over 6. And to get this angle, you can just take this part. So to calculate this part, you would just take pi minus pi over 6, which gets you 5 pi over 6. And since it's negative, you just add a negative sign. And then you need to find the third quadrant, which would be pi plus pi over 6, which is 7 pi over 6. And since it's negative quadrant, just add a negative sign. and this is also in the range. So you have 4 answers in total. 1, 2, 3, 4. This answer should not be part of your answer because it's not in the range. So question 9. Solve the following simultaneous equation. You can rewrite this, and this would be your first one. Use the laws of indices to add both the e and ln 1 will be 0, so y equals 2 for x. This is your second equation. Now you can just equate these two equations. Actually, you can just sub it in here. 4, 16. Y equals 16. So that's the answer for x and y. Part B, solve the equation giving your answer in exact form. So first of all, you can rewrite this to get 2x e to the power of 2x minus 1. And to do this, you can just inverse this. And then times 6. So if you rewrite the entire equation, it will be 10e 2x minus 1 minus 11 equals 6 over e to x minus 1. And since you have e to the power of 2x minus 1 on both sides, you can let y equals to e to the power of 2x minus 1. 10y minus 11 equals 6 over y. Then you just rearrange. And then you plug it into the quadratic equation to get y equals 3 over 2 and y equals minus 2 over 5. And e to the power of 2x minus 1 equals to 3 over 2. And same thing here. This will be ln 3 over 2. This would be ln minus 2 over 5, which gives no solution because ln cannot be negative. So this is your only solution. Question 10. In this question, all distances are blah blah blah, and a particle P is at fixed point 0 at time t equals 0. A particle P is at a fixed point origin at time t equals 0. The velocity of P is given by this for t larger than or equals to 0. So find the exact value of t for which velocity is 0 for the first time after P leaves the origin. So velocity 0, 3 sine 2t. If you rearrange sine 2t, And sign will be positive in the first and second quadrant. So if you plug this into the calculator, you should be getting 0 and pi. And the pi would be, you would get it from pi minus the base angle, which is 0. So it's just pi. And since the question wants the exact value for which the velocity is 0 for the first time after it leaves the origin, it cannot be t equals 0. So the answer is t equals to pi over 2. Find an expression in terms of t for the displacement of p from the origin at time t. So you have the velocity and you want to find the displacement, you would have to integrate this equation. Integration of sine would be minus cos 2t, and then you divide by 2, which is this part inside, and the differentiation of this part, and then add the constant. So displacement equation is this, and you want to find the constant. So at time equals 0, the displacement will also be 0 because you wouldn't have traveled any distance at time equals 0. So you can just substitute into the equation, and C would be 3 over 2. And the displacement equation is this. Find the distance traveled by p between this time period. Okay, so to do this, you have to look back in part A, where it tells you that the velocity is 0 at time equals 0 and time equals pi over 2. So you will know that the particle has actually stopped at time equals pi over 2, and you will need to calculate the distance between 0 to pi over 2 and pi over 2 to pi. And since you have the displacement equation, you can just plug it in. And it would be the same for both, so you just times 2, which gets you 6. Question 11. The tangent to the curve at the point where x equals 3 meets the coordinate axis at the points A and B. The point with coordinates A lies on the perpendicular bisector of the line AB. Find the exact value of A. So for this question, there's actually 2 parts, and let's just focus on the first part for now. The first step would be finding the tangent to this curve. To do this, you can get the coordinate first. So just sub 3 into the equation to get 2. So the tangent meets the curve at 3, 2. And to get the tangent, you can differentiate the equation. Okay, so this is the gradient for the tangent. And use y equals mx plus c to get the equation of the tangent. So the y is 2, gradient 1 over 4, x3 plus c. And c would be 5 over 4. So the equation is y equals 1 over 4x plus 5 over 4. And this is the equation of the tangent. And it says that the tangent meets the coordinate axis at points A and B. So you should know that if it meets the axis, one of the x-axis would be 0 and one of the y-axis would be 0. And you'll be finding y here and x here. And since you have the equation of the tangent, you can just substitute the 0 into the equation to find A and B. Okay, so you have the coordinates of A and B. You can find the equation of the line AB for the second part of the question. To do this, you can get the gradient first. And keep note that it's actually the perpendicular bisector of line AB. So the gradient would be -4. And since it's a perpendicular bisector, you can get one of the coordinates from the midpoint of AB. So to calculate midpoint, you would be doing this. So this is the midpoint of line AB, and you have the gradient. So you can just plug it into y equals mx plus c. The y will be 5 over 8. This is the gradient, and this is the x. So c would be minus 75 over 8. This would be the equation. But since they want the point with coordinates A, you can just sub it into the equation. And A would be minus 15 over 8. Okay, last question, question 12. It is given that this equation is x larger than 0. Find the differentiation. Give your answer in this form where a and b are integers. So firstly, you just differentiate this equation first. This is the chain rule, by the way. Okay, so this is the form that is required in this question, and then hence find the integration of this. Okay, so this is a continuation of part A, and you can use the information you have from the answer. So if you integrate the answer, you will be getting ln 3x over x squared, which is this equation. So now that you have this equation, you can rearrange and by splitting it that way. And then you move that part to the right side. And since you want this, only this part, you can take -2 out to get that part. And then rearrange again. And this entire part will be times by -1 over 2. And you can integrate this part first. So x to the power of -3, you add 1 to the power, so -2 divided by the power again, and add the constant. So if you rearrange, you should be getting -1 over 4x squared plus c. So this will be the answer. Okay, so that is it for this paper. Thank you for watching, and I hope this video has helped you solve this paper. Do comment if you have any questions.